Hi everyone and welcome to LearnAid's question analysis. My name's Ada and today I'll be taking you through question 7 from the 2016 chemistry exam, which looks at organic chemistry and your reaction pathway section of the study design. As a bit of a heads up, we'll only look at part A of the question as part B isn't relevant to the current study design. And before even reading the question, guys, what I recommend is when you get a chart like this, have a quick skim through because oftentimes that will help you out and you will be spending less time reading the question word for word and instead using that time to answer the question and then check through your working out where necessary or check through your answers basically. So I'll just read through the question. Butanoic acid is the simplest carboxylic acid that is also classified as a fatty acid. Butanoic acid may be synthesized as outlined in the following reaction flowchart. Now we can see as a first hint here that we've got but1ene, which means we're starting off with an alkene. And I can see straight away without needing to read all the parts of the question that they want a structural formula for this. So I can start drawing the structural formula. And just remember guys, when it comes to drawing your structural formulae, show all the bonds. Like this is particularly more relevant for alcohols. It's very easy for students and even tutors like myself sometimes to get carried away or feel lazy and just sort of leave out that OH bond, but you don't want to be doing that because that's not really a structural formula in that case. Alright, so I've drawn my but1ene there and I'm happy with it. So moving on, I can see that I've got reagents to form compound Y. The trick here is to figure out what is compound Y. I know my end product is butanoic acid, and that's a carboxylic acid, and it's also been implied in the question. And in order to form a carboxylic acid, I need to have alcohol oxidation, so a primary alcohol to be oxidized. So personally, I would go straight to identifying compound Y first and just writing in that compound Y is going to be butan-1-ol because that is a primary alcohol, and when I oxidize it using dichromate or acidified solutions of dichromate, I'm going to end up getting butanoic acid. And now I can look at, well, okay, what reagents do I need to form butan-1-ol from but1ene? What I need is water and acid catalyst. So phosphoric acid catalyst. You can write the word catalyst. And then from here, I can look at this and be like, okay, now I've got butanoic acid and it wants me to draw the semi-structural formula. So semi-structural is a more condensed version of the structural formula. So what I'd need to be doing there is drawing it out as CH3, CH2, CH2, COOH, and that's done. So I've basically followed the diagram and filled out parts 1 through to 4. Now question 5 is a bit of redox for you guys. It's not directly organic chem related, it's more redox. So having a look, it says write a balanced half equation for the conversion of dichromate into chromium ions. So what I like to do, and I will write it a bit bigger guys, so it will sort of be outside the line, CR2O7 to minus. What I like to do is I like to write it out like this, give myself a bit of room, and then CR3 plus. And now we need to use cohes to balance the equation. So that's just an acronym to balance your equations or complex half equations. Basically what you need to do here is cohes, so key elements first. Looking at the chromiums, there's 2 on the reactant side, 1 on the product side, so I will just put a 2 here. Now they're balanced. Then the next step is to balance your oxygens with adding water to the opposite side. So we've got 7 oxygens here, so I just add 7 waters here. And then what I need to do from there is balance my hydrogens by adding H plus or protons or acid to the other side. And I've got 14 H plus ions, so I just add 14 H plus to this side. That plus was a bit too shifted. And then I'm writing in my states as I go as well. So now I need to add electrons, and it needs to be electrons to the more positive side. And I can see here that the net charge on my reactant side is positive 12 and on the product side is positive 3. So I need to add enough to make them equal. And in order to make it a 3 plus charge on the reactant side, I need to add 9 electrons. And that's done. So guys, if you're ever stuck with just figuring out if it's an oxidation or reduction reaction, you can refer back to your oxidation number rules and figure it out. So in this example here, we've got chromium ions as just being 3 plus charge. And then if I try to figure out the oxidation state of chromium in this, it's easy, it's a polyatomic ion. So remember, everything has to add up to equal the total charge on the ion. So we've got oxygen has -2 and we've got 7 of it, so it makes -14. And then we've also got chromium, but 2 lots of it. So basically chromium is going to be positive 12 divided by 2. So it's going to be 2 lots of positive 6 to make positive 12, and positive 12 minus 14 is going to give you, minus 14 is going to give you a -2 charge. I hope that was helpful, guys. Keep an eye out. We will keep posting out more of these videos, and if you enjoyed the video, found it helpful, feel free to subscribe to our channel. Thank you.